Hi, so in this video we're going to talk about how to graph trigonometric functions. So first I want to start by reviewing the unit circle. So a couple videos ago we learned about the unit circle. So I'm going to provide a link to the unit circle videos in this video so that if you don't know what that is, you can watch it. So just make sure your annotations on YouTube are on so you can see those links. So anyway, let's review the unit circle. So the unit circle has radius 1, and if you move an angle theta on it, then the coordinates of a point are cosine of theta, comma sine of theta. So if you turn an angle theta on it, the point on the unit circle, after you turn that angle theta, the coordinates are cosine theta, comma sine theta. And remember, pi over 2 radians is 90 degrees. Pi radians is 180 degrees, so 180 degrees of a circle. 3 pi over 2 is 270 degrees. And if you don't know what a radian is, I'll also provide a link to my radian video right now. And then 2 pi radians is 360 degrees, so we're back where we started on the circle. So we're going to use this to graph y equals sine of theta. And remember, sine of theta is the y coordinate. See, over here it says sine of theta for the y coordinate. So basically on this graph down here that I've circled in orange, we're going to plot sine of theta for different values of theta. And theta is the same theta as on the circle. So this theta axis down here that I'm circling in orange right now, it's the same as this theta. So that's the theta that we're talking about. And we're going to graph sine of theta. So the y on this graph, the y coordinate on this graph will be equal to sine theta. So we're graphing y equals sine theta. So let's start at when theta is equal to 0. So that's right here. When theta is equal to 0, the sine of theta, which is, remember, the y coordinate on the unit circle, when theta equals 0, what's the y coordinate here that I'm circling in red? Well, it's just 0, because that's on the x-axis. So the y coordinate must be 0. So the point we have to plot here is 0, 0. Okay, so that's good. Now let's plot pi over 2 radians, which is 90 degrees, which I've labeled up here. Circling in red right now. So pi over 2 radians, let's see, sine of theta, which is just the y coordinate, is 1. Because remember, the unit circle is radius 1. So if we're at the top of the unit circle, the y coordinate is 1. So sine of theta, which is the y coordinate on the unit circle, is equal to 1. Now if you'd go the same thing, pi radians on the unit circle is 180 degrees, and over there the y coordinate is 0 again. And down here at 3 pi over 2 or 270 degrees, 3 pi over 2 down here at 270 degrees, the y coordinate is actually negative 1 because we're below the x-axis by 1 unit. So sine of theta is negative 1 over there. At 2 pi, we're back where we started, which is at 0. And then 5 pi over 2 is another rotation of pi over 2, so we'd be back at 1 again. And then at 3 pi, we'd be back over here where it says pi. So now we're going on another revolution around the circle. So at 3 pi, it would be 0. And actually, if you plot this for smaller angles, like in between pi over 2 and 0, you'll actually find that it makes a wave shape. So let me do it in green. So as you can see, it makes a wave shape. And then if we went negative angles, so these negative numbers here, that means when we're turning this way on the unit circle, so counterclockwise. Counterclockwise. Before we were turning, clockwise. So before we were turning counterclockwise, negative angles mean we're turning clockwise. So before we were turning counterclockwise, negative angles mean we're turning clockwise. So negative pi over 2 is the sine of theta is -1. At negative pi, it's 0. And at negative 3 pi over 2, it's 1. So we can connect the dots for negative angles as well. And as you can see, that just continues the wave. So the graph of y equals sine of theta looks like a wave because the sine of theta repeats itself every 2 pi units. So we say that the sine graph has a period of 2 pi. So what that means is that sine of theta equals sine of theta plus 2 pi. So basically it means the distance between these two peaks is 2 pi. So as you can see, the wave is repeating itself every 2 pi units. And the distance between here and here is also 2 pi. So the wave repeats itself every 2 pi units. So we say that it has a period of 2 pi. So that's how we graph y equals sine of theta, and that's going to be it for this video. And in the next video, we're going to talk about how to graph y equals cosine of theta. So hope you like this video. Thanks for watching.